What we're going to try to do today is to understand how we can control animate objects such as robots, which I brought one with me here, connected to the AWS cloud using IoT, and then understand how we can use different principles such as our voice or a virtual world that we run in a cloud environment to have actively control that robot. Now, I'm going to show some code samples, so some of it is going to be a little bit deeper. If you're into coding or developer yourself, you're going to appreciate those parts, but there are also going to be some fun parts around where we're going to use our voice and our robot itself. So what you can expect from this session here is a better understanding on how we could use AWS IoT in combination with something like AWS Lambda to actually control animate objects. In this scenario, it is actually connected by the last mile via Bluetooth. We're going to have a better understanding of how we can create Alexa skills. And if you're not familiar with what an Alexa skill is, we're going to dive a little bit into that. And you're going to get a glimpse of an engine called Amazon Lumberyard, which I'm going to use to actually create a virtual world in the cloud environment, draw that back up to the screen here. And we're then going to have a look around how we connect that back to the robot and sync that virtual world back to the physical world. And lastly, I'm going to have fun with robots, right? Love my job. So let's start off with the physical world. So with me, I brought a little bit of a smaller robot. I couldn't quite put the big robots into my suitcase. So I decided with me I would bring a small little toy robot. So what you see here is actually a Sphero SPRK Plus. Really, really wonderful toy, also great for kids to kind of play around and build with it. Now, if you haven't seen one of these, you might have seen it's a smaller brother or sister, which is called the BB-8 version, which was one of a similar robot that rolls around. This is the development version, which is translucent, so you can see what's inside. So we're going to take this as a robot, and we're going to navigate that robot around. Now, how do we do that? Well, this robot here itself is controlled via Bluetooth, so you can control it via your phone, for example. What I thought that would be nice to do is, could we use another great piece of hardware, such as the Raspberry Pi, to actually control that robot? So again, with me here, I brought a little Raspberry Pi, which you should see up here. That Raspberry Pi will then use Bluetooth to connect to this robot. Now, that's our last mile. So that would allow us to control this robot from our Raspberry Pi. But I said we want to control it from our cloud environment so that we can bridge an outside world to it and that we can also extend its capabilities around what's possible. So what we're going to use here, sorry, that went back. What we're going to use here is we're going to use AWS IoT to actually have the Raspberry Pi talk to the AWS IoT platform. If you're not familiar with AWS IoT, it's a service that allows you to securely connect up to billions of devices to the AWS cloud environment, have messages sent back and forth, and define certain rules on how you exchange those messages. Now, the other thing is I think it's always great to give a robot a voice, right? So I wanted to give this robot a voice. Now, there's that one issue. This robot here doesn't really have any place where I could play audio files from. So I decided, well, I have everything connected to the cloud environment, so why did I not send messages to my cloud environment and forward this to a device that could actually play a sound sample and as such give my robot a voice? So what I chose to use here is, I have a MacBook here with me, so my MacBook actually listens on the AWS IoT topic. So as this robot will roam around, it will send messages of what it's doing. I'm rolling around, I'm stopping, I'm changing my language, etc. It will send that using the AWS IoT platform to the AWS IoT cloud deployment, and it will then, my laptop will listen onto those messages and can then play an audio file accordingly when it wants the robot to talk. Now, I used a few open source projects to make this happen. The first one that I used is the Cylon JavaScript SDK, Cylon GS SDK. Really great if you're into robotics. They have multiple connectors to different kind of toy robots, but also more professional robots. There was one available for Sphero straight away, making it really easy for me to control the robot. And then to connect to AWS IoT, I used the AWS IoT device SDKs. So you find that we have the AWS SDKs, but for IoT, we also have a specific device SDK, which is trimmed down to run at even on constrained devices. So the idea is now that I should be able to control the robot, and as it rolls around, it will send that information back and forth, and my speaker will then give certain voice outputs to give this robot a name. So let's try to understand that a little bit better by actually having a live demo. So we can just switch over to my screen. Perfect. So what you see here is actually my Raspberry Pi, and the first thing that I'm going to do is I'm going to boot up my drive script and place my robot up. There we go. My robot came alive, and what you see now is it connected to, I'm going to make this a little bit bigger so you see that better. It actually connected to AWS IoT, to both a topic where we're going to send its commands back and forth, but also to an IoT shadow state, and I'm going to explain in a bit what that is. So what I can now do is I could go to my AWS console and, for example, look at my AWS IoT deployment here and listen on a specific topic. I'm going to listen on a topic which is Sphero/anything behind. Now I'm going to subscribe to that topic, and I will now see if messages are coming true. The first thing that I now do is I will send control signals to the robot itself to actually start rolling around. So we can just get the camera on the robot. We'll be able to actually control this robot. And you also see that it sends back JSON messages to AWS IoT, and AWS IoT can then pick that up. So, for example, if I look here, we see that these messages came through the platform. Now, obviously, we can have a little bit of fun with that. We could change, for example, the language. And now we speak Cantonese, a bit of Chinese.
안녕하세요.
I'm still working on the Australian version. So let's switch back to my English here. So what we can do now is we have the ability to actually control this robot remotely. Now, important to notice, this is a connected device, meaning that this device also sends sensor information back, such as, for example, collision data. If we receive a collision data, I could play an audio sample file. Let's try this again.
Ouch!
There you go. Doesn't want to be heard. And there we see it detects a collision, sends that back, and my MacBook will now pick up those messages and knows there's a certain collision that happens, so I play the sound file with this, ouch. Let's go back to the console, and we also see here the collision coming through. So the first bit is done. Let's go back to the slides. So we connected our robot to our AWS IoT cloud. We connected it last mile via Bluetooth, and we also connected a sound sampler, which would be my MacBook here, that listens onto that AWS IoT topic. We can control it, and we have a voice for the robot. Now, why do we connect something to a cloud environment? We could argue I could do this completely locally on my Raspberry Pi. We do it because we can extend the capabilities. So let's have a look at what we did here. The piece of code that we're running is actually the Cylon SDK, as mentioned. This Cylon SDK will help me to actually connect to the robot using Bluetooth Low Energy, and that's the second part that you see at the bottom. We will then connect to AWS IoT. How difficult is it to connect to AWS IoT? It's pretty much one line of code, which is what you see here. So if you have the AWS IoT device SDK, all that you need to do is initialize a new device, and then you indicate a few things like the security certificate that you're going to use to authenticate the device. Similarly here, I also created a device shadow, and the device shadow, we'll see that in a little bit. We're going to use that to actually change the color of the robot. Now, how do we publish information back and forth? When we have this device connected to the device SDK, again, will allow us to easily publish or subscribe to an AWS IoT topic. So in this scenario, the Sphero robot will both publish and subscribe. It will publish its movements and its collision data, but it will also subscribe to the information of commands. Should I roll around, etc. My MacBook similarly will subscribe to the data feed and will understand if there's a certain message coming through. I play a sound file, so I give the robot a voice. Now, if a message comes through, we can handle it in this little snippet of code. The actual code is a little bit longer, but in this snippet of code, for example, if the Sphero gets a command that says you should roll, the robot will start rolling. Now, the last thing that I haven't addressed yet is the thing shadow. So right now you see there's a color here. It actually shines red. That color is stored both locally on the device, but also in my cloud environment, and that allows me to change the color on both ends and synchronize it accordingly. Now, why would we do that? Well, we want to take it one step further. We actually don't just want to give our robot a voice, we also want to talk to our robot. Now, again, this robot doesn't have a microphone, so how am I going to do that? Well, I figured there's this really cool thing called the Amazon Echo device. Now, if you haven't heard of the Amazon Echo device is a device that allows you to actually talk to the Alexa voice services. The way it works, it has a certain wake word. You can set it to different wake words. The default wake word is Alexa. If you say Alexa, it will listen to you, and you can give it certain instructions, commands, or ask it questions. Now, I didn't bring the Echo device, which is the one that you see on the right side with me. I brought the smaller version of it with me, which is the Echo Dot device here, which I have connected to the PA system. So let's try to understand this, how that works. Alexa, say hello.
Hi there.
Alexa, how are you today?
I'm good. I hope you are too.
I am. I'm waiting for the session to be able to have a beer. Alexa, where are you right now?
I'm here and my head is in the cloud.
Ah, her head is in the cloud. And that's useful because that means any kind of voice instructions that I give are transmitted to some extent to that cloud environment, which I could tap onto to actually control my robot. Now, how am I going to do that? I'm actually going to create a skill. So anyone can actually extend the ecosystem of these voice services. By default, there are certain skills that you can enable that other developers have built, but you can also create your own skill. And I'm going to create my own skill to actually control this Sphero robot. How am I going to do that? Well, when I create a skill, I need a certain backend that talks to my robot. Where am I going to put that? I'm going to put that into AWS Lambda. If you haven't heard of AWS Lambda, it's a great place to execute your piece of code in the cloud, fully managed, without thinking about servers. So in this scenario, that's exactly what we're going to do. So we're going to use an AWS Lambda function that talks to my voice services. When I say a certain specific thing, that Lambda function will talk to my AWS IoT platform and will then transmit that back to the robot. So let's go back over to my laptop and have a quick look at this. And I'm just going to wake up my robot. It has a timeout after a while.
Hello.
There we go. Hello. And you see that we actually have a certain thing in AWS IoT which has that shadow state. That shadow state right now is set to a certain color, and I could edit that and say my desired color would be green. And let's just have the camera once on the robot now. And if I hit the button here, it will actually change its color. So we change the state in my cloud environment, and then it will synchronize back to my robot. Now that allows me to use now my voice to do that. Alexa, ask Sphero to change its color to white.
I changed Sphero's color to white.
Alexa, ask Sphero to perform a stunt.
Sphero performs a stunt now.
There you go. Alexa, ask Sphero to change color to blue.
I changed Sphero's color to blue.
And there we go. So now we extended these capabilities. Let's go back to the slides. So we now see the reasons on why we actually want to connect our robot to my cloud environment. I can now take any other capabilities, such as these voice services, and combine them to my device, or potentially to hundreds of thousands of devices if I desire to do so. So there's value in connecting it because now I can use other APIs, in this scenario, the Alexa voice services, to actually talk to this robot. So what else can we do? Oh, yeah, that was actually the demo. There you go, we did the demo. What else can we do now? Well, we understood how that thing shadow works. That thing shadow allows us to actually change its color, and we can actually update that using this piece of code via our AWS Lambda function. What's our AWS Lambda function doing? Well, it's an Alexa skill, so it listens to a certain skill. I called that skill Sphero. That's why when I say Alexa, ask Sphero to do something, to do a stunt or change its color, it will use that Lambda function to talk to the robot via AWS IoT. So we have the physical world established. We have a robot, we can control it via my cloud environment, I can use my voice to talk to it. What I haven't quite gotten into yet is what is the virtual world part? We have the physical world established and we have it linked and connected up. So the next part that I want to talk about is how can we create a virtual world? Well, there are many different engines out there to create fantastic virtual worlds or games itself. Today, I want to use one engine that you might or might not have heard of. It's called Amazon Lambda. Now, Amazon Lambda is a AAA grade game engine that is deeply integrated, obviously, with AWS and also with Twitch. And by the way, it's free and it comes with the full source. So that's cool. So I'm going to use Amazon Lambda to create a virtual world. How is that going to look like? Well, it will look something like this. So Lambda itself is an engine, so it can render virtual world, but it's also an IDE, an integrated development environment, where we can create that world, connect it back up together, and create a certain logic. What I show you here is a low-res version of what Lambda is able to do, and in just a bit I'm going to show you what nice graphics we can actually render with that engine. So how do we now connect a virtual world that we render somewhere in a cloud environment back to our robot? AWS IoT, right? Makes sense. We're going to connect it via AWS IoT. Whenever we have that robot in the virtual world that navigates around, we send information of how it navigates around to the physical robot, and we're done, right? Sounds easy. Now, there's a bit of an issue here. If you think about a virtual world, it renders at a certain frames per second, 60, 80, depending on the graphics processing unit that you have, up to hundreds frames per second. So you have updates of the position in that virtual world that happen sub-second, right? Maybe hundreds of times within a single second. Could I send hundreds of times within a single second all of that stuff to AWS IoT and synchronize with my robot? Yes, I could, but it probably wouldn't be a very smart or cost-effective way of doing it. So what we're rather going to do is we're going to use Amazon Lambda, and we're going to use a component that is called Cloud Canvas. Now, Cloud Canvas allows us to access any AWS resources within the Lambda engine itself. So in this scenario, I'm actually going to access an AWS Lambda function. So when my robot roams around in the virtual world, I will call a Lambda function. But not every time the robot changes its position, because that will be too often and the frequency is too high. So I will decide to only send changes once in a while. So how am I going to do this? Well, very simple. I'm just going to establish a certain frequency when I want to send updates of my current position, and I will then calculate the delta between where I was previously and where I am now. So in the virtual world, we get coordinate system. Generally, that's an x, y, z, of x, y being obviously the 2D aspect, and the z coordinate being the robot jumping. Now, I did scrap the z component because this guy can't jump quite yet. So I had to look at the x, y coordinates of the camera that is exposed. I'm going to take the position at a certain frequency. In this scenario, I took it every second, and I will then calculate the delta between those different positions every second. I will take that delta and send that to my Lambda function, which in effect will send that impulse of the delta change of its position via MQTT to my robot here, and the robot will then follow suit. Now, here's the most difficult part for me. I always think it's easy to connect stuff to AWS and play around with robots, but I did have to use trigonometry to actually calculate the deltas. That was probably tough. I know everyone in high school can do that, but these days are long gone. So you got to use a bit of trigonometry. I can't even say the word. There you go. Trigonometry. To actually calculate, obviously, the deltas between the positions. So that's obviously around what is the new position, what's the impulse that I get around a certain 360 degree in this scenario that I want to roam around. And I will then take that delta and send it out via AWS IoT to my device. So what can we do now if we plug that all together? Well, we understood the physical world component, AWS IoT, the Raspberry Pi talks via Bluetooth to my robot. We also saw how an AWS Lambda function can be used, for example, to take my voice, talk to AWS IoT, and to that Raspberry Pi. Now let's try to actually use a virtual world that is rendered in Amazon Lumberyard, update its coordinates to the Lambda function, and then send it to the robot. So let's switch over to my screen here. So the first thing that I need is I need to actually run the Amazon Lumberyard engine. Now, I do have a MacBook here. Currently, the Lumberyard engine runs on Windows, so I decided, how about I open up an Amazon workspace? Now, if you haven't heard of an Amazon workspace is basically an easy way of running a virtual desktop in the cloud and have that sent back to the client here, which is my MacBook here. We also have a graphics workspace, so it comes with a GPU. That's the one I'm using here. So ideal if we need to render graphical workloads on, for example, a thin device. So this would perfectly run on a very thin client like a Kindle Fire or a tablet or what have you. Now what you see here is in that workspace, we have actually the Lumberyard IDE, the editor, running here. And within that editor, you can see I can actually play around, I can navigate, and we see we have a virtual world here. I could modify that virtual world a little bit if I want to. So, for example, here this rock, how about we make that a little bit bigger, so it allows for that kind of visual editing of that world. Now, the engine will then take care of the rest. So in this scenario, I created, for example, a player here. That player is this little robot, and I can now use my keyboard to actually navigate around. Let's have a little look. This engine comes with wonderful different things, like, for example, the particle engine that allows us to render nice fire like this, or if we go under the trees here, you might or might not see that. You see it as the little sun rays coming through. So I created a small little virtual world here. Now that virtual world, I connected it to my AWS IoT and cloud environment. Why is that useful? Because I can actually extend its capabilities now. So for example, I can use my voice to interface with that virtual world. Alexa, ask Lumberyard to say hello.
Hipster says hello.
There you go. Hipster just said hello. Let's bring this to the next level. Alexa, ask Lumberyard to make it snow. Oh, she didn't hear me. Alexa, ask Lumberyard to make it snow.
We made it snow.
There we go. So we now use the API capabilities, or the voice services, I should say here, to actually talk to my Lumberyard. How did we do that? Well, we used the AWS cloud environment as a glue in between those both two things. Alexa, ask Lumberyard to stop snowing.
No more snow it is.
All right, cool. So if I navigate this robot around here, right now you see this robot is not following suit yet. That's on purpose. I actually haven't connected it yet. So the next thing that I'm going to do is I'm going to wake up my robot, and then we can get the camera also on the robot itself here. And what I'm going to do now is I'm going to connect my virtual world now and tell it it should send its updates every second to the physical world. Let's try that.
Lumberyard connected.
And there we go. And now we see the robot now becomes reactive. So if I now roam around in that virtual world, we see that the physical world will follow suit with a very slight delay based on latency that I have to this event side. But we will now replicate these exact movements. And of course, all of it works together now. So I could say, for example, Alexa, ask Sphero to change its color to green.
I changed Sphero's color to green.
Awesome. And if we go back to the console here, we see now that those are the deltas that are slowly coming through. We see, for example, we received the delta on the color. Color was changed to green. And here we see the deltas of the impulses that the robot is doing. So if I navigate this one around in the virtual world, we see the physical world follow suit based on the impulses that we send back and forth to the robot. All right, let's switch back to the slides. So what have we established here? Well, we established, first and foremost, me having fun with robots. So that's always great. But the other one thing that we established is, why do we actually connect things together? Because it extends our capabilities of what is possible to do. Now, I don't expect any one of you of going home and say, I need to have the Sphero robot that listens to me here. but it demonstrates a few very interesting principles. The first one, the last mile of any IoT deployment mustn't be to the internet. In this scenario, it is Bluetooth to actually talk to the robot. But we will then use a strong platform such as AWS IoT to easily synchronize information back and forth. Synchronize information like the caller, but also send it commands back and forth using specific topics. We can even listen to these specific topics to extend its capabilities then. In this scenario, we gave it a voice. We can then also use other APIs. In this scenario, we used the voice services here to actually create a skill. And with that skill, we can now interface with the robot. And lastly, that allows us, of course, to say, if I have a virtual world that in this scenario rendered in Amazon Lumberyard, I can, of course, take these coordinates and glue it all together with the combination of AWS Lambda and AWS IoT to really create a full-fledged product at the end. Now, with that, I hope that was insightful, and I want to thank you very much for your attention. Thank you.